Good morning. Welcome again to this next OpenCloudification webinar. My name is Ulrich Saldesacht. I'm happy that you are participating again in one of the monthly activities that we organize in order to support actually the development of the use of open cloud technologies into the wider market. Specifically to support IT companies in Flanders in the first place, of course also throughout the rest of Europe and even globally. We do this on the back of a project which is called OpenCloudification. It's a project that started a couple of months ago together with a number of partners. We created a website for this in the opencloudification.com. You can find a couple of the resumes that we are doing in terms of different types of open cloudification technologies that exist, but also on the perspective of how these developments are actually progressing and how they can be best used. We do this as LSEC, but also together with two other partners, one being IMEC ID Lab, which is basically the University of Ghent in Belgium, focused on clouds, on internet and data already for the last couple of decades. And then with a third partner called the Beacon, basically an entity that supports startup IoT companies and also scale-up IoT companies in Antwerp, together with the city of Antwerp and also the port of Antwerp. We on our side as LSEC are slightly more focused on cybersecurity, but also in the perspective of making sure that cybersecurity is part of a total integration of potentially transforming IT systems, doing digital transformation, or on the overall doing business online, but then with the cybersecurity perspective in the back of mind. So with OpenCloudification, we aim to do a number of things, including organizing webinars like this one. We have been organizing a number of face-to-face sessions, and hopefully you will be able to attend some of those as well. These will be unfortunately only in Flanders, due to the fact that this project is very much supported also by the Flemish government, by the institute of the agency, which is called VLAIO. And together with our partners, we will be organizing also different types of documentation, basically white papers and other materials that can help out in facilitating the take-up, in this case, of open cloud technologies. You see a major sandbox in there. In the previous webinars, we talked about the sandbox that was set up, basically a Kubernetes cluster, which is being made available to companies who would like to start utilizing open cloud technologies or expanding and testing out some capabilities in that platform. My colleague Luca, who will be talking later on today, gave some examples in one of the previous webinars on the use of AI technologies in the basis of cloud. And he will be talking definitely also a little bit more about that later on, but then from a security perspective today. Because today is really about the security of open cloudification, and a major theme and an aspect, of course, that you have to keep in mind. When we take a look into the cloud native computing framework, in this case, there's plenty of different pieces of technologies available. Many of those definitely from the open source perspective, that we have been detailing also on our OpenCloudification platform. And then we are also focusing further on during the different webinars and sessions. And so today, a number of those we'll also talk about a little bit more in depth during this today's session on security for OpenCloudification. So what does that entail? Well, there's a couple of things. So I'll do a little bit more of some basic backgrounds on what it contains in terms of cybersecurity. Then Luca will talk more about how best practices in terms of securely deploying in cloud services model can be done. also which open source tools that exist that can improve the security of the cloud. As I mentioned already, focusing on the way and use of AI with cybersecurity, but in this case then focusing more on the cybersecurity aspects than on the AI aspects. But in any case, using machine learning, for instance, to improve cloud cybersecurity for that matter. And then I'll close again the session of today with a topic which is done together with the Cloud Security Alliance, where, as you might see behind me here, LSEC is actually the running and leading the BILIX chapter. And so the Cloud Security Alliance is a global alliance of people working on specific cloud security capabilities and developments and challenges. And together with them, there's a security priorities list that was created for 2023. Some very practical guidance on a couple of items that you might find useful when you start deploying into open cloud type of components. And there will be many other components that we might not be able to entertain you with today, but that will be picking up at a later point in time. For instance, capabilities such as key management in the cloud, the use of basically open source types of technologies, and how to better do vulnerability assessments inside, which is related to some of our security bill of materials types of activities, SBOMs. And then in the third place, maybe also how to practically improve your Kubernetes security and how to follow that up. So today we'll be starting with a couple of these elements, and then taking it further in future webinars. But let's get started why we are doing actually the things that we're doing. So in the first place, I think that the basic consideration is that cloud is still today omnipresent and continuing to be also very attractive. There's many different reasons why companies can choose to go into the cloud, and why it also makes sense when considering digital transformations that cloud could be a very valuable alternative. But definitely also from a security perspective, for the reasons that are mentioned here. There's definitely economies of scale. You do see that there's a very basic capability already of security available that you can build yourself upon. So it helps you actually getting faster into a security landscape, and also to a large extent much more mature. So it helps you raising your basic levels of maturity quite fast. Also on a very relatively simple manner, in the sense that many of the components are already there and being made available, which is good, of course. But in some cases, as we'll be talking about later on, those capabilities, of course, have to be activated, have to be properly configured, and have to be properly monitored as well. On the other hand, of course, using cloud and open cloud technologies brings along the fact that it's open, and therefore many of the known vulnerabilities in those platforms will be known pretty quickly to the rest of the world. And if the rest of the world, including also the adversaries, so the malicious users, if you like, can see which cloud you will be using or you are using, they can, of course, use those known vulnerabilities and start easily trying to attack you, either on purpose or just as basic part of a wider service. On the other hand, there's also many different components that we can see that will help basically some very core functionalities, which will be very difficult for us to deploy on ourselves in this case. Things like, for instance, data sovereignty could actually be supported in this case by cloud. And for instance, also when we start increasing the infrastructure capabilities that security might offer, things like confidential computing, multi-party computation, which can be very expensive on an enterprise level to set up, but taking it as a service from a cloud operator could be much more easily being set up. So therefore, those things could be actually also promised to be more sustainable over time when it comes to cost. So in terms of cloud and security, we could talk about a couple of security premises and definitely take those along further because they will be definitely also helping you making your business case in the cloud native transformation. Or using open source cloud technologies. So definitely one of those components is the decrease of the marginal cost of security. So by adding additional security features, you will raise the baseline security of your environment without therefore increasing significantly the cost. So, of course, if you want to monitor everything and if you want to put tabs on everything, it will be it could be an expensive thing because, of course, as you know, computing power is the real cost next to storage in cloud environments. So that is something to be careful about. But at the same time, there's many mechanisms that exist to be able to do that properly, and also with a focus on keeping controls of the cost. But you can do that pretty quickly. Cloud-enabled automation delivers security enhancements, and this is definitely something that we see as well. I mean, you can really do a lot of automation in this space because you have mechanisms that allow to do this type of security posture detection from the cloud level and also from the cloud service providers, which allow you to much faster do deployments and making sure that there are security updates that can be set up. However, there's also some considerations. Normally, most of you won't be having issues with this, but do take into consideration that if you're not properly securing, for instance, your cloud infrastructure, it could be utilized for things like crypto mining, which means that you will pay basically the bills for, in this case, the crypto miners or the in this case the malicious users of your cloud environment to use your infrastructure, and actually you will pay the bill of the compute power of their use of your cloud infrastructure. It has happened. It does happen still today. I think one of the more known cases about this was a couple of years ago with Tesla, where some of their AWS instances were quite easily available, in this case for crypto miners. And so they use simply for a specific point in time your cloud infrastructure, and then they move on. But you will see in the end the bill, of course. So the cost for you in order to do that is can be quite steep. Whereas in this case, maybe the revenue for the attacker might not be that huge. But therefore he has been using your powers, and so you will have to pay this bill. Others in this space could be ransomware. Ransomware could, so one example is the ransomware families from Networker, for instance. So where the cloud can be used, of course, as a distribution mechanism if you do not have any proper investigation and inspection on what happens in your cloud environment, which then can be distributed quite easily to all your desktops and your endpoints. And so, of course, that means capabilities for those ransomware service providers. So this is really you becoming part of a criminal business model, if you like, that you will have to see how your systems will be encrypted, and you will have to start either paying the ransom or try to get back your backups, which might be in this case in the cloud. And another one could be actually where you basically have a ransomware attack that has happened, or a ransomware incident that has happened on one of your endpoints that could be transferred into your cloud environment as well. So those types of cases do exist, and so therefore inspection of malwares and both on endpoints as well as in cloud environments are definitely to be considered. Even if you would be putting specifically virtual containers of desktop tools also in your cloud environment for easy restore and access. So do take into account that those virtual machines those containers could actually also contain, obviously, these types of malwares. And then there's quite a number of other types of security challenges that we are seeing throughout the industry happening. There's data leaks, of course. I'll be talking about another one later on. So do take that into account, that you have to still make sure that your data is properly protected, that there's access controls and authentication, but also encryption, for instance, in terms of the data being stored. So specifically when talking about personal identifiable information or just personal data overall, just make sure that that's being protected properly as well. In some cases, it's been known that from a governance perspective, you might also have some challenges in relation to your identity protection. So public clouds basically can be pretty much on the open towards the outside world, and anyone with credentials and that has been able to access your consoles in this case can pretty quickly reconfigure your whole cloud environment, and that might be a bit of a challenge. So from a governance perspective, of course, you have these single platforms which are also being managed through the cloud providers and being offered to you as an end user. But of course, if anybody really has the major keys to the platform, to the castle, they will of course be able to change quite significant things. There's unfortunately not yet that many strong frameworks on cloud native security. Some of them are there, which are, let's say, the typical traditional cloud cybersecurity frameworks, and then in this case the 800.53 from NIST. But next to the ones that we provide from the Cloud Security Alliance, it can be sometimes a bit of a challenge in order to provide strong cloud native security capabilities. So that's the reason why we're also putting your attention on this. If you are considering cloud native technologies, that you do pay a bit more of attention, of course, in making sure that your whole cloud environment is properly secured. And then thinking about open source, thinking about cloud native, and therefore a bit more towards open source, or just overall open source cloud technologies, you have to also consider, of course, your supply chain compromises that might happen. Log4j being an example, but there's others as well. So for instance, that's the example of PyTorch, there, which had some compromises in the Torch Triton in this case. So some packages which are being provided from, let's say, the GitHubs in this case, and these could cause quite significant impact, of course, on your environment, because you're actually inviting basically vulnerabilities into your own environment. And so if you don't know about those, then those could be causing quite significant harm. So do take that into consideration, that if you do this, that there's of course some open source technologies that need to be much more carefully monitored during install stage, that you at least know which vulnerabilities exist and how to properly protect them, but also during the lifetime of your cloud environment, that you do keep them into consideration. Another one, unauthenticated API requests. The number of open APIs available that we can find is quite significant. We'll talk about that later on, also how to cope with it and how to mitigate them. But just to give you an indication, already since 2015, don't have the most recent data here, but you can see the steep increase of the number of APIs which are connected to AWS. And so still many of those are just open to the public. So it might cause a bit of a challenge sometimes to see that. So another consideration that security in open cloud infrastructures is could really be sometimes of a challenge. And if you then offer, like we do in our sandbox environment, basically the capability of testing and using the platforms for free during at least some point in time, There's even people that will be trying to use that free time, that free space, to start putting in what's called free jacking, and basically start utilizing your cloud environment to do their own stuff, and maybe even go lateral and find other capabilities therefore. Today, talking about open cloudification, we also take into consideration that you would do that from a multi-cloud perspective. So you might do that on your own infrastructure, if even still using your open cloud technologies. But you might also be combining it, both private and public, or you might have different public cloud providers that provide you services. So, which is of course causing a bit of an additional challenge, definitely when it comes to security and to cybersecurity. So things to keep in mind as well. And then, of course, next up is, of course, Kubernetes, including and having many different opportunities, of course, being offered to, and thanks to Kubernetes. But of course, also today, due to the fact that it's a major opportunity for many organizations and companies, it also it can be providing some threats, maybe not today, but definitely in the future. And to give you an example, in the latest DEF CON, there was a capture the flag on Kubernetes. The way it was set up was basically as a platform with some flags that could be captured in relation to a movie here. But the basic thing was for the attackers, the ethical hackers in this case, that participated into the contest, to discover HTTP services, and then using a couple of different mechanisms to find where some of the cubes were, and then from there on trying to identify which of those cubes existed, and then further go in depth into trying to discover what services were made available, and then just step by step attacking the Kubernetes in this case, and also being successful in doing so. So what really needs to be done, and we can and we will be talking about it in a later webinar as well, how to better protect your Kubernetes environments. So at least to start with making sure that you have the proper logs. In this case, in really the proper logs. So yes, there will be auditing that can be made available, but you have to turn it on. And so in this case, it's mainly to turn it on in a more simple way. And then maybe even also to run your cubes in this case in such a way that it's easier also afterwards to detect which types of attacks have taken place. So if you see the API events happening on the right hand side, those would indicate that there's really something happening. So you could put your sensors to these in order to try to figure out already today whether your Kubernetes are under attack. So with this, I just wanted to point out again that thanks to Open Cloudification, we are able to do these types of activities, but also thanks to both DigiHub and Digitalis, we as ELSE can also help out in ensuring that there is that these types of transformations can happen, but also that we can help you in securing these, thanks to the support from the government, either the Flemish government in the case of DigiHub, or in the case of the European Commission and the European institutions, thanks to the platforms such as Digitalis, which is our European Digital Innovation Hub, specifically there to transfer manufacturing companies. So with this, I'd say I'll hand it over to Luca to pick up on some practical suggestions to basically start managing and activating your cloud security in your cloud setup. Good morning, Luca. How are you?
Hello, good morning. I'm good, thank you. Thank you for your presentation as well. Let me share my screen, so you should first enable me to do so.
You're good to go.
Thank you. Okay. Can you see the actual presentation? Okay. Okay. Yeah, thanks again, Ulrich. Good morning, everyone. My name is Luca Gattubiggio. I'm I'm an innovation manager from EdSec. I hope my voice is also starting to get familiar with all the webinars that we are organizing, and from time to time for all the participants here, you might have already seen me. Today, I'm gonna talk about cloud security, as Ulrich already explained. I will focus mostly on some of the best practices when you have to deploy your cloud service model. That's gonna be different, of course, based on the model that you would like to deploy. As a cloud service, I'm talking about software as a service platform or infrastructure as a service. Then we're gonna have a little deep dive in some of the open source tools that could be used to improve the security of your cloud. And then again, a little focus on AI and cybersecurity, especially when using them in cloud. And as last point of the agenda of today, Ulrich is gonna give some extra information about providing security guidance for all the critical areas in the cloud. So let's get started. First point would be trying to protect your cloud. That's one of the main goals of OpenCloudification. So when I'm talking about cloud computing models, as I briefly mentioned, I'm talking of the three main computing models that have been defined so far. There are plenty of them, but we can categorize mostly on these three areas. From top to bottom, software as a service, it's basically also defined as the application level. So if you're a customer that applies for this type of cloud computing model, you're basically running and managing just the application part, and everything from the infrastructure to the software that is used to run that application is going to be handled by the service provider. So usually you also refer to this as the end user application level. Platform as a service is between the software and the infrastructure. So you have access not only to the application, but also to the platform that it's used to build the application and it's used to manage. But you still are not having the complete access to the infrastructure that is below and it is used to run your application and your platform. An example of that is it could be Kubernetes, for example. Sometimes is defined as platform as a service, as if you have only control to the cluster of Kubernetes without having access to the nodes of Kubernetes. And then infrastructure as a service is the most flexible level, as you have directly access to the building blocks for your cloud. So I'm referring to resources like the computing power, data storage, networking, and so on. And of course, based on the service model, you will have different types of responsibility, because if you have everything on premises and you're building your entire cloud stack, then you will have to manage everything. While moving up to the pyramid that we just saw, you're getting less and less responsibilities. So in an infrastructure as a service model, all the building blocks that I was referring to, all the resources are still managed by the provider, and you will have to take care only of everything that you build on top of that. And moving up to the pyramid, platform and software, you will give part of these responsibilities to the provider itself, which means that at the very top, at software as a service, you will only have to take care of everything that is running inside the application. Which also means that based on your cloud model, you will have different type of security issues that you will have to take care of. And that makes kind of sense. Like if you have to manage the entire infrastructure, you have to protect the infrastructure as first place, but then also everything that is built on that infrastructure. So a customer that is responsible for the infrastructure. We'll have to take care of the operating system, all the applications, and the data that are running there. So some examples of security issues might be the fact that you have to be sure that there aren't unauthorized access, there aren't data breaches, there aren't denial of service attacks, and so on. If you're managing and you're having access to the platform only, then you have to take care of application and data only, which means everything that refers to the designing of your application, anything that needs related to the code used to build your application, code injection, but also data leakage from inside the application, any type of configuration error that runs inside your platform, and so on. And again, at the very top, only software. So you have to be responsible for anything that happens within your software, means data privacy, identity management, access control to the application, all the vulnerabilities inside the application. So if we take them from top to bottom, for software as a service, usually you have some advantages in terms of responsibilities because everything else is it's took care by the provider, but which means you're more flexible and you can focus on your application. But you still have to make sure that all the security concerns that are inside your application need to be took care of. So everything, as I previously mentioned, like the data loss, all the type of unauthorized access inside your application, insider threats, account takeover, phishing, malware, ransomware, they need to be addressed. And a good way to do that, for example, is work with partners that can also help you assessing the security or implementing the best practices in the framework of your application in a way that you're sure that your data and the application itself is secured. And then if you go to the platform, well, then it starts to become more complicated because you will have to take care of the entire pipeline. I'm talking, for example, of the CI/CD pipeline, a platform that constantly gets updated and constantly gets changes. You there will have multiple interfaces, multiple APIs that needs to be secured. You might have code and dependencies that might be vulnerable, so you have to check on that. But the execution of poisoned pipelines, for example, are an issue. Not having proper access control, misconfigurations, attacks from supply chain, secrets, monitoring and logging that are missing, several issues at this stage, which it gets even more complicated when you're talking about the entire infrastructure, of course, because there you need to have the complete visibility of everything that is happening inside your cloud. And you have to have control over the entire cloud infrastructure and platform and application, which means that it might be difficult to monitor everything and auditing everything that is considered the security posture of the entire cloud environment. And in that sense, you should also make sure that you're maintaining a consistent and effective security policies and controls in the entire environment. And there you have any type of risks from inside or outside. It might be that you experience insider threats or data breaches. You might have malicious actors that could try to exploit vulnerabilities or trying to access your sensitive data. So you need to make sure that you enforce properly data encryption and protection of your entire cloud and try to protect for them, for example, when they're trying to bypass authentication and authorization mechanisms. Plus all the vulnerabilities, all the threats that can happen at infrastructure level. So malware, again, ransomware, denial of services, denial of service attack, distributed denial of services, and so on. If we see that more on a higher level, there are some best practices, some guidance provided by, in this case, the Cloud Security Alliance. It is sort of guidance in actual steps that you can follow to help you with the creation of on the deployment of your cloud environment. So the first step would be, of course, identify all the necessary security and compliance requirements and any existing control that you will need or you would like to use. Select the cloud provider, the services, and all the deployment models that you would like to use. Define the type of architecture, assess the security controls, identify control gaps, design and implement the controls that are missing and you would like to use gaps, and then manage changes over time. Ulrich, I'm asking quickly if everything is fine because I see that there are some internet issues. Am I still online? I hope so.
Did you ask a question?
Yeah, I'm getting notifications that it says that my internet is not.
You're okay.
Doing well.
Everything
okay.
is perfectly clear. No worries.
Okay. Okay. Sorry to interrupt this. So going step by step, just some extra information that might be useful. When I say identify necessary security and compliance requirements, means that once you want to build your cloud, then the process starts from the designing part. So you would like to make sure that everything that is needed is available and identify those requirements. Those might be something related to industry specific regulations. It might be something related to internal policies, security policies of your company, for example, for your organization, any type of data protection laws and so on. So you want to make sure to first identify those. And then also based on that, select the cloud provider, the services and the deployments that you would like to use. And in this sense, I mean both what type of cloud option you would like to opt for, a public cloud provider, build your own private cloud, or for example, have an hybrid or a multi-cloud environment in which you combine public and private, for example, and also the right type of cloud models, as I said, software as a service, platform as a service, or infrastructure as a service. Once you've done that, you can define the architecture, and in this case, not only the resources, but I'm referring to everything from the networking part to the data storage and so on. But of course, you have to include the security aspect on it, and I'm going to talk about this quite soon. And as a next step, you will have to assess then the security controls that you already have in place and you would like to use for the cloud environment, which also means try to identify what are the gaps there, because assessing and having those controls are the only part that allows you to make sure that everything is secure, which also means that if there are some areas in which you would like additional security measures, then you will have to design and implement them as well to fill this type of gaps. And that means new access controls, for example, strengthening some encryption methods, additional network security measures, and so on. And as a last step, as a last suggestion, you will have to manage all the changes over time and keep track of them, like make sure that everything is up to date, regularly check on the posture of your cloud environment, monitoring the new threats, make all the changes that are necessary based on industry standards and so on. And then if we want to focus a bit on specific areas, I'm gonna talk about some of the common concepts that you can hear while talking about cloud security. In this case, I'm going to focus mostly on the architectural part, the networking, and the identity and access management. So related to the architecture, often you will hear the word security by design. It's not only applied to the cloud, but it's usually it's mostly for the software side, but it's also adopted for the cloud deployment. And in this case, it's becoming like a quite used development approach to ensure the security and the privacy of your cloud. And the concept is that you would like to consider the security during the designing phase, not only building an environment and infrastructure and then put on top of that the security, but it's something that you would like to have since the beginning as part of the design. And that helps you in terms of make sure that all the steps, all the controls that we already mentioned are in the correct place and are correctly functioning to provide extra protection to your cloud. 4 steps that can be followed to achieve the security by design concept is to, first of all, once again, understand what are the requirements of your organization or your software or your cloud, outline these policies and try to map them to something that will be controls that you will deploy in the environment and use for your environment. With that, you can build a secure environment that can fit all the requirements that you've been identifying. And at this point, as an improvement step, try to enforce the use of templates and automation security, and trying to automate the security measures with this approach in a way that you will remove any type of extra vulnerability or issue that might be happen, for example, when we're including human errors. Another buzzword when we're talking about secure architecture is what is defined as a well-architected frameworks. This is mostly related to the cloud, especially when you move to a public cloud provider. They all have their own specific well-architected framework, which is basically a sort of guide, a set of guidelines and best practices. And the idea is that they provide this to help you understanding what are the pros and cons for each decision that you will make while you're building your infrastructure in this case. But also you will learn from them what are the best practices that they define for their specific cloud, which means that there are multiple well-architected frameworks. Each of them is tailored for the specific cloud provider, but in general, the main high-level guidance is more or less the same. They usually divide those per pillars that are defined, pillars of architectural excellence. This is, I think, the definition from the Azure cloud, but more or less those pillars are always the same. So they aim to reliability, security, cost optimization, operational excellence, performance, and so on. Then moving to networking, another security best practice that is gaining some momentum lately is the zero trust model. It's more a definition than an actual model. And the idea behind is to never trust and always verify, no matter where the request in this case will come from. Which means that instead of assuming that everything within your organization or behind your firewall is safe, you will always presume that a breach can happen. And you always want to verify that each request originates from a trusted source, as if it was coming from the outside world. So what they use usually is mutual authentication of the devices, but also they only provide access, a specific service will always and only provide access to devices that can identify themselves, combined with extra information like user authentication, for example, or machine authentication, but also health status. This provides pros and cons. Some pros are the fact that it's a more flexible model, especially if you are in the cloud. When you think about a cloud native application that is built on microservices, for example, you can see this model applied to authenticate each microservice to each other. And it's also a good way to prevent attackers from gaining access to multiple devices or multiple resources together, because they will have to manage to have access to each single resource. And it's for that a more secure environment. It's still debatable, the applicability, and it provides more or less security, but against unauthorized access or against the attempt to access sensitive data, it is a powerful model. On the other hand, not always is possible to achieve the transition from to a fully zero trust model, especially if you're also including in-house servers or servers or components that are outside the cloud. And in that sense, sometimes you have to reimagine and redesign the way, for example, that your user or your developers are accessing and authenticating against some of your resources, because in that case, that would be more containerized on each part of the cloud, on each component. Probably we're gonna talk a bit more about zero trust models once we will have a webinar on the networking part. I'm thinking, for example, on all the service mesh, that most of them, all the service mesh tools are applying also the zero trust model. And moving to identity and access management, we constantly hear about the least privilege principle. That's self-explanatory, but I'll quickly define what that means. It literally means what it says, like trying to provide the minimum level of access or permissions needed to perform a specific task in your environment. So this is becoming a fundamental step, a very best practice to apply in all the different environments, not only the cloud. And it can be extended not only to human access, because applications will have to interact with each other. So you will try to provide the same type of principle to application systems and any type of device that requires privileges or permissions to perform any type of task. And so you want to ensure that only the minimum requisites are provided to access any type of resource. This reduces the cloud cyber attack surface, because you're shortening the possibilities, for example, of an attacker to have access to other services once he gains control of one of these. It helps with the streamline of compliance and audits, because you have more control over the entire networking and the access and identity management. It stops the spread of malware for the same reason, and improves user productivity, because you're sure that your user will have access only to the resources that he will need. And another two concepts that we can get together about identity and access management are the role-based access control and the attribute-based access control. They're both methods to control the access to resources or access to information in your cloud. And the main difference is the way that they use to authenticate a user, or to grant access to a specific resource. In the first case, you define a role, which could be an administrator role, user role, developer role, and so on. And then depending on that role, a user have more or less privileges, more or less access to a specific resource. And on the attribute-based, you then define something that is determined by characteristics or an action type or anything that could be used to differentiate the type of users that can access a resource. And for example, the job title, time of the day that you can access a specific resource, how sensitive that resource is, and so on. Okay, this concludes the first part of my presentation. We're gonna have a bit of a deep dive into some of the open source tools that can be used. We're gonna refer first to the areas that I just mentioned to continue the presentation. So I identified some of the areas that might be relevant. So the networking part, of course, but also identity and access management, as well as the security information and event management that you would like to have in your cloud to improve your improve its security. But also more interesting areas that are less mentioned, like the policies part, the entire cloud management, or dealing with all the updates of your components and devices. So I'm going to start with the first one. It's going to be quick because for network security, I picked one open source tool that I think everyone knows. When we're talking about remote connection, you will probably think of using a VPN. And so if you want to pick an open source VPN, I think OpenVPN is one of the most famous, if not the most famous, for several reasons. The strong security features from TLS, TTLS, the perfect forward secrecy, and so on. It's quite highly customizable and flexible. It's easy to deploy, especially on the client side, maybe a bit more complicated on the server side. And offers multiple authentication methods that are quite useful in different scenarios. So I'm not going to focus on OpenVPN itself, but I would like to stress the fact that it has to be part of your security strategy for the related to the networking part, of course, of your cloud. And it has to be combined with other components, like it has to be part of a well-designed network architecture, again, the well-architected network section in this case. You can combine it with firewall rules and access controls to be sure that only the traffic that you want to allow will gain access to your cloud. And it can be helped with the use of monitoring systems and IDS or IPS system. I'm talking about component that can help you with the auditing and the logging part to check on all the activities that are happening in your cloud environment. And of course, talking about OpenVPN itself, it offers multiple types of encryption. It has to be set up correctly. Otherwise, I wouldn't say it's useless, but it still can provide some vulnerability. On the identity and access management, a very famous and used tool is OpenIAM. It has several features from the identity and access management aspects, from the single sign-on and the federated identity management, the user provisioning and deprovisioning, role-based access control and attribute-based, as I just mentioned them, but also extra feature like the password management. It has a specific portal to check on that. The audit and compliance report, multi-factor authentication, adaptive authentication, those are all features and components that can help you strengthening your cloud security. And for example, from their website, you can see what are the advantages that the use of OpenIAM can bring to your cloud. Some of the examples are here on the right of this slide, like they talk about how it can improve the customer experience. They're also recently including AI-powered tools to improve the effectiveness of their tool, but I'm going to talk about AI later on. The security, automating all the identity life cycle of the events, more visibility, for the various identity, productivity, and contractors improvement, compliance activities, cost of ownership, and so on. On the left side, it's an interesting architecture example on which you can see that this type of tool can also be used, since it works with connectors, on multi or hybrid cloud solutions. In this case, they're showing how you can manage everything through the OpenIAM cluster that can be connected both from cloud applications and on-premises applications. Like you can see Windows and Linux connectors that works together, and you have a centralized way to manage your entire infrastructure. And about security information and event management, I think two of the most famous tools that are used in combination in this case are OSSEC on one side and the ELK stack on the other side. And I'm gonna briefly describe both of them. OSSEC is the actual security tool that you would like to use as a security information and event management tool. It helps you, it has a lot of features that are used for the monitoring part and also to help you protecting and as an incident response solution. So it monitors file integrity, it provides log analysis, intrusion detection, active response, compliance, and so on. There are several features for that. And on the other hand, you have the ELK stack, which is the combination of three quite famous open source tools, the Elasticsearch, Logstash, and Kibana. They quite often used together. I think everyone knows Elasticsearch. If you don't, it's a distributed search and analytic engine that it's used, especially when you have to handle large volumes of data, both structured and unstructured. And it's quite fast and scalable to provide, search, aggregation, analytics capabilities, and so on. And it's used in combination with Logstash, which is the data processing pipelines that it's used to collect the data, transform, enrich everything that then will be passed through Elasticsearch, your search engine. And Kibana is the visualization tool that you could use to explore this data, visualize, create dashboards, charts, map, but also alerts, reporting, and now they're including, again, machine learning capability, because machine learning is becoming dominant. An example of how you would deploy this architecture and how you will combine these two tools together. So imagine that your users are interacting with your application, for example, that is running in both virtual machines or container and virtual machines and containers. And in each of them, you will have the OSSEC agent that monitors and collects data from with the user interaction. And all this data will be sent to the OSSEC server, which is the one that provides the computing part. It will be inside your cloud. It will do the computation and check, for example, intrusion detection, check on the logs, and provide the security part. But it's also it is often used together with Logstash to improve then the visualization part and the storage part. So you will use first Logstash to create and get this data and transform it in input that can be passed to your engine, to the Elasticsearch engine. And at that point, you have the tool that keeps your data, your logs, and you can visualize it through Kibana, for example, so you can have a clear overview on everything that's happening. And of course, in this case, I'm only showing here the flow from the user interaction to the visualization, but if you will have to include alerts or anything specific, there are several arrows that are going out from the OSSEC server, for example, from the search engine, and so on. Sorry. Okay, we're halfway through the areas that I wanted to present as an open source tool to improve your clouds. The next one are going to be part of the CNCF landscape that we are constantly mentioning in our webinars as the tools that are open source and they're becoming more and more popular, more and more used. A couple of them are graduated projects, so are already available for production environments. And I'm going to start with policies. One of the most famous one, as I said, a graduated project is Open Policy Agent, or OPA. It enables policy-based control for cloud-native applications, but not only, and infrastructure, which means that you have a declarative policy language. They used a specific language, which is called Rigo, but they also are available with different languages, JSON, for example, or declarative languages like JSON or YAML, if I'm not mistaken. The idea is to express those policies as code. So you literally write as you would write code, but you're expressing policies. And it's quite famous because it's flexible. Its integration, it can be integrated with a lot of systems and frameworks because it uses REST APIs, the RPC protocol and libraries, which makes it quite flexible, together with the combination of the fact that it's scalable and performant. So it's designed to handle high throughput and low latency scenarios with a very, very minimal overhead. And the policies themselves can be extended with custom function, which make this tool even more flexible. Plus the fact that it can be deployed in several platform and environments, from on-premises to the cloud or Kubernetes clusters, for example. How does it work? Well, to give a very simple example, let's imagine that a user wants to request access to a specific application, to a service, or to a web page, something that is included in your cloud environment. Then before do that, it will send a request to OPA. It could be, in this example, a JSON value, a query in JSON. So OPA will match this request with the policy, the internal policies that have been defined and set up for your specific cloud environment according to the type of request, the users or the machine or the service that are requesting this. And then once it received the input and it compare it with the specific policies that are in place, it will output the value, the return value, saying if the user or the service in this case are allowed to access this resource or not. And it's quite powerful, especially in the integration part, because it can be combined, for example, while you're building your application, let's say with an infrastructure as code framework, and there it can also stop. So if you're not allowed to deploy a specific resource because the policies don't allow you to do that, it will stop the entire process and it will avoid that resources are accessed without the right permissions, for example. So a very powerful tool. Talking about cloud management, Cloud Custodian is not yet a graduated project, but it's probably going to become soon because it's gaining a lot of interest as it helps with the management of your cloud resources. The idea, the main value there is the fact that offer not only the definition of policies like OPA in this case, but also cost optimization, compliance, garbage collection, and real-time remediation, which means that what is defined as governance as code, again, as code means writing everything as you would write code and manage everything as you would write code. And it's quite flexible because it runs on instances or locally. And now they're also included serverless, but only for AWS Lambda at this moment. but probably we're going to talk a bit more about cloud management when we will have a specific webinar on the management of your cloud. But here, for example, you can see from their webpage, they show how you can simplify policies, defining them from several cloud providers or even Kubernetes just in few lines of code. And last open source tool that I would like to present today is the update framework. I think I already mentioned it in a couple of previous webinars. This is also a graduated project, so again, available for it's production ready. It helps the developers and the users to securely update your software. It offers several features like the cryptographic signatures for the integrity and authenticity of updates, multiple update sources, fallback mechanisms. Is designed to be resilient to key compromise, to specific attacks like key compromise, rollback attacks, freeze attacks, and so on. And it's, again, quite flexible, and custom policies can be defined when and how you want to update your components. So this is also one of the tools that might be worth to have a look at. We might probably have a specific session for it. Okay, last part of my presentation will be about EI and cybersecurity. The previous webinar, I showed an example of cloud deployment in which you use a machine learning model. In this case, was an anomaly detection model to help you improve the security of your system. And it was more on the practical level, more on the practical side. We actually showed the code and the deployment of a Kubernetes cluster. In that case, we were using Jupyter Hub as the notebook to deploy that. And in this graph, you can see for example, the integration with Lambda functions or data that is collected from a logging system, for example, that goes on a S3 bucket as a storage, and then it triggers an event, get checked on the anomaly detection, and then user, for example, is alerted that something's not going as expected. But yeah, in that case, I would recommend to check on the record of the last webinar if you want to know more on the practical level. But what I didn't, and what has been asked, is to be more generic on why, for example, you would use artificial intelligence for cybersecurity in first place, and then why you would move to the cloud to do that. The reasons are multiple. Artificial intelligence or machine learning models can provide higher accuracy compared to us. They're more able to adapt over time. They're more capable of handling big data. They can see patterns, especially over complex data. They might be able to identify threats that you don't even know are there. They're faster to detect and react to those type of threats. They can automate repetitive tasks. They're faster when we're talking about deep data analysis, for example. And again, they're the only way to protect against the use of AI from malicious users. But why moving to the cloud? There are several advantages for that. Two of the main ones are the fact that the cloud could provide endless between brackets resources. I mean, we're talking about public cloud. Of course, you're gonna pay the more you will request resources, but you can see that as the provider, something that can always offer an infinite amount of resources. If you need more resources to deploy or train your models, because it's well known that artificial intelligence models or machine learning models will require a lot of data and a lot of computing power to be trained and deployed. So the cloud is a perfect environment because technically it has infinite resources. Plus, as we mentioned already, the shared responsibilities can help you because you won't have to, if you want to focus on the deployment of your AI to improve your cybersecurity components, you might not care that much on handling the entire infrastructure that is below, for example. So you can leave, in this case, the AWS to take care of everything that is physical, or the software that is below your application, because you want to focus on the cybersecurity side. And of course, the cloud provider already know this. They already, all of them, all the major cloud providers are offering artificial intelligence services, both on platform side, so entire ecosystem in which you can deploy your machine learning models. You can train them. I'm talking of entire frameworks like SageMaker, Vertex AI, Microsoft Machine Learning Studio, and so on, but also services that are now already available, and they are AI powered. So services like ChatGPT, which is now included in Azure. But in general, there are a set of services and components and platforms that the cloud service providers already have in place and are available right now. Services that include the improvement of AI. We're gonna also talk a bit about how you can improve those with some simple examples. But I'm talking of, yeah, AI and security services combined together, but platform, as I mentioned, machine learning, dedicated resources, virtual machines and containers, for example, that provide a GPU for the computing power that is already for AI purposes, deep learning frameworks, solutions that are made from third party that already configure all the software, all the platforms that you would need to deploy your machine learning models, and so on. And for most of those frameworks, even the cloud providers are often relying on open source components. The most famous open source tools for deep learning, for example, are PyTorch and TensorFlow. They're both open source. They're the main component offered by basically all the cloud service providers, as well as Jupyter Hub Notebook as the engine to then write your code if you would like to write your code. So it makes sense to move to the cloud because some of those services, some of those tools or platforms or the solutions that are there might be already there and might be useful for your specific use case when you want to use artificial intelligence or cybersecurity components that needs to be improved. Maybe you don't have to start from scratch, but you can pick one of those components to improve what you would like to deploy in your cloud environment. So for artificial intelligence as well, it's important to stress the security by design model, the well-architected framework. We mentioned both of them basically. It also applies for artificial intelligence use cases. And in that sense, you have to make sure that the identity and access management are secured. So again, least privilege, we mentioned this already, separation of duties, meaning that making sure that each of your team has the correct duty and permissions to access the specific resources, cloud security more in general for all the layers, and apply all the several security controls. Data has to be protected in terms of artificial intelligence. Data covers an important aspect of the entire use case because AI models are fueled with data. They can train only mostly with data. So you have to make sure that the data is secured, is encrypted, both when it's in transit and at rest. And as much as you can, try to keep people away from the data. The less access they can get, the better it is for the security of your environment. And if you can, of course, automate as much as possible. Those are basically a repetition of what are the best practices when we're talking about well-architected framework. It continues with the compliance part, incident management and response. We more or less talked about this as well. The monitoring and discovery part is important, both for monitoring, alerting and auditing your systems, but also discover and investigate if something's going wrong. And of course, keep everything up to date and follow the industry recommendations that constantly keep track of the development of the new threats, for example. What would you have to do if you want to start this development of AI solutions to improve your cybersecurity in the cloud? Well, first of all, I would recommend to have a check on what's your in-house knowledge, specifically for the cloud in first place, but also on the machine learning knowledge, because, well, it's not the same if you're working on premises or if you're working with a specific software within your organization and then you're moving to the cloud. Don't expect to be just a change of environment. It sometimes changes the entire framework. You have to take into account the fact that you will have to train and learn a lot of new concepts and different framework and the use of different software and tools to deploy maybe the same thing, but instead of on premises in the cloud. So an in-house check of the knowledge for cloud and machine learning components are essential, because that could help on the definition of what are the services that you would like to use, or trying to identify what would be useful for your specific use case. And in that sense, of course, it also makes sense to consider what are the open source solutions that are available that you can integrate in your use case. And last but not least, the cost models that can differ, and try to get what is the best, not only in terms of quality, but also in terms of cost in the cloud, because as we said, artificial intelligence or machine learning models require a lot of resources. So you have to take this into account when you're moving to the cloud, for example, to a public cloud provider, because you're gonna pay for all the resources that you're gonna use. To give some examples on why and how it would make sense to use artificial intelligence to improve some of the open source tools, for example, that are already available in cybersecurity. Here are some examples. OpenIAM, I already mentioned. There are several tools. I'm reporting here just a few of them, but there are way more for each specific category. But as we define them as low-hanging fruits, basically, those are tools that can be used and they will have a high impact in terms of revenue or improvement, just applying artificial intelligence on those systems that are available to be integrated with external components, for example. So let's pick the example of the intrusion detection system. In this case, Suricata is one of the most famous. There are multiple ones, as I said. We also mentioned OSSEC, for example, also provides intrusion detection system features. What you usually have is the fact that you define a set of rules that you would like to have in your IDS system. And then based on the data that it receives, it will take a decision, right? So the login of this user is benign because it's behaving as usual, or it follows the rules that have been set. But maybe the attackers can start to learn how your system works and try to avoid or try to exploit this set of static rules to gain access to your data, even if they wouldn't be allowed. And in that sense, you can imagine that using artificial intelligence to adapt based on the data that you receive could be a nice improvement, because if it starts to see a pattern in which an attacker tries to guess how to access the data, even if it's not allowed, then it can dynamically modify the set of rules that you have inside your IDS system. And then it would be way more difficult for the attacker to avoid those rules. Or when we're talking about vulnerability assessment system, you can use AI, for example, to give a score on the level of criticity or level of how dangerous it could be, the type of vulnerability that you have while you're exploring your cloud environment. Web application firewall is usually defined on the most common threats that are available at the time that you set up your firewall. But for example, the data that you're getting or the attackers that are attacking your specific system do not follow or try the 10 most common types of attack, but they will try with the 15th, for example, which maybe is not something that your firewall is set up to. But an artificial intelligence models that learn from the data that they're trying to attack using different types of vectors, then can readapt the firewall to being more able to resist on those types of attack. Or another way is to check that your password is secure. And again, you can, for example, provide scores on that. The identity and access management, as I said, OpenIAM is already using itself some AI-powered solutions to improve the user experience, for example. But also when you're checking the data alteration inside your storage, for example, or if something has been changed without your permission, you can use artificial intelligence to see how likely that data has been changed, for example, by a malicious actor instead of an admin. And the adversarial robustness toolbox in that case is directly specific for AI libraries, and they will help you with the attack of tools and libraries that are used to see whether your solution is able to resist to different and various attacks. So this concludes my presentation. We've seen what are the best practices depending on the service models that you're using, but also on more and higher level, what could be some of the best practices that you would like to deploy in your system, making sure that it's protected. A bit of a deep dive on the open source tools that can improve the security, and then the focus on AI and cybersecurity combined, especially in the cloud. So I'm gonna leave the stage to you, Ulrich, again for the last point. As usual, if you have questions, comments, you're curious to know more about some of the specific tools that I mentioned today, some of the frameworks, some of the best practices, we're happy to help. You can check everything on our website, the edsec.eu website, and the specific project website, opencloudification.com. So with that, I finished my presentation. I will stop sharing the screen.
Thank you very much, Luca. It was very comprehensive, also very lengthy, but you gave some good examples on the different topics, and definitely also all the practical experience. I think from what I'm seeing here is that one of the things that we will be doing, and that may be something that we can start working towards. Number one is there's a couple of tools that we haven't yet listed on OpenCloudification so that we need to update for sure. But also is to do something like more hands-on session where we take some of these different open source technologies, open cloud technologies on security as well, and just guide people from one step to the next in really deploying and setting it up, and of course also maintaining it. So I can definitely think that could be a useful next step. So before concluding, I think one of the things I wanted to share are a couple of very practical security challenges that we see happening in cloud environments on a day-to-day basis. And I mean, it's to a large extent repeating what has been said firstly by myself and then by Luca afterwards. So really priorities that we would like you to consider in when you're deploying your cloud environments, or when you're basically providing your cloud environments. They're very practical things that you should consider on a day-to-day basis, and taking also the different suggestions that we already took over the last hour and a half to a next step. So with this, the reason why we're doing this is twofold. As I mentioned at the beginning, there's of course the OpenCloudification activities that we do within LSEC as Digital Cybersecurity Catalyst. We work with quite a number of cybersecurity organizations providing commercial tools and services to you. So in this case, that's still valid, but we also offer you alternatives on the uses on the basis of open source technologies. And it's really to help those companies advancing, which are trying to develop their the technical new developments, and maybe are a bit constrained in terms of capabilities, in terms of budgets or what have you. So then open source can be a valuable alternative. It might not be, let's say, doing everything that you can find within commercial tools, but many commercial tools also are basing themselves upon open source technology. So that goes in both ways. And we are also supporting this towards the cybersecurity community in order to pick up some of these technologies faster, in order to develop themselves faster when it comes to endorsing new capabilities and technologies, and to be more competitive, of course, in the market as well. So we, on the other hand, do this also from the perspective of the Cloud Security Alliance, as I mentioned at the beginning. So we do run in Belgium. You can see it front and back now. The Cloud Security Alliance, Cloud Security Alliance, in this case, Benelux chapter, already for the last decade or so, where we have a community from both vendors as well as end users that have a cloud-first type of perspective. So there's about 10 IaaS and PaaS cloud attack vectors that we wanted to indicate here, and also with some ideas towards mitigation. So basically, how to cope with them, and all of those have been set up on the basis of a risk analysis model. In this case, we used Stride, where there's also the taking into consideration where the responsibilities are, and knowing that definitely in the case of public cloud infrastructures, you can rely upon what the cloud service provider will be offering you. But never to forget that it's always a shared responsibility model. So yes, the cloud service provider has its things to do when it comes to security, and which are quite significant already. But they will provide you basically in an IaaS or PaaS model with some tools that can help you improving the cybersecurity of your cloud environment, and the cloud security in particular, of course. So we also indicated from this perspective where you as a customer also need to pay attention. It also relates back to this model that you see underneath, which is basically the MITRE ATT&CK framework, where many of the current cloud attacks are being recorded. Basically, the threat analysis are being done on where those cloud attacks are being discovered, and then also to find an appropriate defense mechanism, an appropriate mitigation mechanism to counter that. So therefore, in this case, we are relying both upon expertise available through the Cloud Security Alliance globally and through the MITRE ATT&CK framework and defense architecture also globally. Now, the results that you can see here are preliminary elements of a white paper which will be published pretty soon by the Cloud Security Alliance. And so those are documented in a white paper in this case, and where you can find also more information and more details about them. And definitely then specifically on the shared responsibility models or the strike model. So to get into this, so number one of the things that are being seen are really things like exploitable workloads. So what happens is basically different workloads are being set up, for instance, in a Kubernetes cluster. Once an attacker gets an initial foothold into this cloud environment, which could be basically by brute force attacking, for instance, on an endpoint device, and therefore getting the credentials to the cloud environment, and therefore maybe also getting access to the workloads in this case. He can start using his way to move laterally between the different nodes, between the different workloads that are active, and without you even knowing, really trying to catch what's available there on the one hand side, but also starting to launch things that I mentioned at the very beginning, so crypto miners or ransomware attacks. So this is what we do see happening. So the things that need to be done here in order to mitigate is, of course, try to protect those different workloads from being exploited. That sounds quite obvious, and that is indeed also the most natural thing to do, but it is often forgotten. And so therefore, the suggestion is to really put some focus on those. Just check out which workloads you have running in your environment or which you are planning to set up. And then from that perspective onwards, try to see how you can further protect those different workloads with the different mechanisms and tools available, being made available by either Kubernetes or additional cybersecurity management layers. Another one is something that we see happening quite often, and Luca mentioned quite extensively the use of identity and access and the necessity for it. It is something that we do see appearing quite often. I mean, just the number of virtual machines or containers which have simply too excessive permissions. And to some extent, it's quite normal because many of the cloud operators and cloud infrastructure providers will just provide you access and then expect you to start limiting that down as much as possible. And it doesn't start always from this zero trust perspective or the limitation in terms of capabilities, because of course you have to start deploying it. Now, many of the cloud providers will put some focus on there and try to limit, let's say, new users being created with only very limited restrictive functionalities and permissions. But if you tend to deploy, you tend to copy paste and to just make it easier. And then you tend to forget typically as well that many of those temporary users might have excessive permissions, which then can be obviously utilized to start attacking other workloads or to gain excessive permissions throughout the environment by again moving laterally. So Luca mentioned as well things like least privilege is a requirement here. So when creating new users, limit their capabilities upfront, and only when deemed necessary, or depending on the user policies, on the security policies that you might have, you should then be expanding their permissions and basically allowing other things to be done. Another thing that you can do, as we suggest here, is if you do have to deploy those additional users just for the sake of testing or in the deployment stage, then use temporary access tokens instead of permanent permissions. That allows you as well, in any case, in this case, to say, okay, I will create a user, but maybe he only has the active has the right to live for 30 days, or you change basically the permissions that the passwords are being granted only for 30 days. And building upon this, the other thing is that that we do see is just so many unsecured keys, unsecured credentials, application secrets, which are just dripping. So many of the applications being made also in the cloud, in different containers, in clear text, or credentials being put in clear text, which means, of course, that it's relatively easy to tap into username and password, which is being sent over the wire, and then in this case to tap on this and to reutilize it for a next attack by the adversaries. So known use case when an EC2 instance needs access to an S3 bucket, it's quite usual that that these access keys are being stored to make it easier just to retrieve data, or to just simply update the deployment mechanism. So API keys here as well would be better protected for that matter. So just grant access to the workloads by attaching it to an identity with required permissions is our advice. Again, it's not that difficult to do, and it's actually pretty straightforward suggestions, but it does happen too often still that these are just out in the open. And I put here an example from something not too long ago. So a company called Circle CI, which is used quite often by developers using CI/CD for continuous integration in this case, and there basically the many of the keys, access keys of their customers, developers in this case, that have access to their clients and their customers or employees' cloud platforms, then of course you can imagine how quickly it can scale if you can get access through this platform into different environment of clouds. Exploitable authentication or authorization. So again, something in relation to the identity. So usually, and also there, Luca mentioned it a couple of times, using multi-factor authentication, it's not too hard to deploy. We also put on OpenCloudification some mechanisms that can help you do that, things like Passbolt, so where you can facilitate quite easily how an integration can work with multi-factor, if it's not even already provided by the cloud security, the cloud service provider in this case. Also the suggestion for temporary access in this case. So, but definitely go towards a more granular approach, using a role-based or attribute-based types of identity management. Sometimes what we see happening is unauthorized access to object storage. So again, this really calls not only from the identity of the user getting access, but also limiting access to specific objects in this case. And so also limiting it, for instance, in terms of secure sharing, making sure that there's pre-signed URLs, or using things like AWS SDS or Azure SAS for providing temporary access in this case. Making sure that your networking capabilities are set to private subnets, so that you don't leave everything out in the open, and continuously, of course, use encryption, encryption keys in this case. And number 6 was in relation to third-party cross-environment or account access. And again, here the example from Circle CI. So after the attack, it was also, of course, a challenge to making sure that the users that had access to the platform were only those users that should have had access. But in this case, when you're providing access through a third-party company, is making sure that you can also relate the activities of the accounts that participate there. So again, the call for using multi-factor authentications and limiting access to the place by using the tools which are made available, but are not always therefore set up. and again, also the concepts of least privilege. And as another example, in this case, there's been a hacker community was actually recruiting employees that did have insider knowledge of these types of companies, which have been in the development environment. So if you have a disgruntled employee and he might have access to this by use of his keys, you will not notice it, of course, from his behavior, but there will be maybe some leaked activities that will then be used by the hackers in order to get into your environments. Using unencrypted snapshots and backups, another thing that we see quite often. It's of course sometimes hard to do the full encryption, but it does help. Of course, if you put containers out in the public clouds, which are basically an entire copy of your existing operations, then it's not that difficult, of course, to get access to them on the one hand side, but also once you get access to them is to reopen them and then, of course, start to investigate which types of access capabilities that these containers might have, and therefore also start moving into different directions in order to get more data or basically deploy additional malwares into those environments. So just as a couple of ideas how often it happens. So this is just a perspective from, in this case, an Azure environment. And as you can see, how many of those publicly made available containers are there that we can actually just find by using the right schematics in searches. So they can be found, and once they are being found, they can be easily uncovered. So restrict the review and update permissions in this case, and making sure maybe also that you put your snapshots and your archives in maybe in the archives of another cloud provider, which might be much more helpful in this case. Compromised images, another thing that we see. So if you did do images of virtual machines or put them into containers or something, those can be used as backdoors, because some of those images might actually contain malwares that you might not even know about, but they could be helpful again here for accessing and viewing data which should not be seen, like for instance, in this case, getting even access to cloud administrators types of environments. So in this case, limited the controls by implementing access control policies and specific cloud management tools, which could help in the continuous management of cloud. So another topic for a bit later on. And then, of course, I mentioned it already at the beginning when we were talking about supply chain also in cloud. So the number of public images being distributed, in this case also with some potential vulnerabilities in there, as you can see here. So for this Debian GNU Linux does have quite a number of vulnerabilities. So if you start utilizing those, then do make sure that you have also a good perspective in the form, for instance, like of SBOMs, on which potential vulnerabilities might come along with the use of that specific open source tool. And so there's many of those that go around in public containers. Many of them are known, many are still unknown. So definitely something to consider. Yes, we do advise on using open source tools and cloud native, but also keep it under the hood that you need to inspect that many of those tools could have actually quite a number of vulnerabilities in there. So we do take that also into attention, and suggest here to you as well to make sure that you have a good perspective on this, and using some of the additional tools made available for it. And then finally, another suggestion, it was also mentioned a couple of times by Luca with some toolings. The use of incident management and forensics is still seen not as often enough, and needs to just simply improve. It was already mentioned on the identity scheme. It was mentioned when I was talking about the DEFCON capture the flag initiative on Kubernetes. Logging does help, especially in clouds, because you don't have anything on premise. So it will require, of course, a bit of more of an effort in order to get them. And it will also be much more expensive than when you do that locally, because it does require some compute power and it does require some storage. But there's, of course, ways to do that. And we at least give you the suggestion to at least take into consideration those 5 different types of log schemes and even more, because many of the cloud service providers will be offering you log capabilities, but they might not be turned on by default. So therefore, a suggestion is to increase also some others, like CloudTrails in S3 buckets, in API collections, on who can access the web consoles, who can access the internal AWS service. And so continuously monitoring that for at least 90 days in this case, that will help you getting a better perspective on what's really being done. But also just make sure that they are logged on. For instance, in 365, UAL, for instance, is not by default being turned on. So if you want to make sure that you can get unified audit log trails, then make sure that they are turned on. And so it requires a bit of additional settings. And just again, for you to know that you might see a peak in increase in cost, but still limited then to only a couple of days. And then maybe what you can do as well is, of course, start creating metadata on top of all of this. So you don't really need to keep the logs continuously, but at least that you're capable of detecting what might have happened. So some key takeaways from all of the things that we mentioned today. Yes, there are vulnerabilities, there are attacks happening also in cloud. So it's not because you're moving into cloud that security is off. There are capabilities already offered by the cloud service providers, but still sometimes they require you to act upon. And so it is a shared responsibility. So there's capabilities that you can use in terms of network tooling. Some of the things that we showed, capabilities and tools there. We do continuously watch over the existing vulnerabilities, and so should you. So especially from the different tools that you have and that you have deployed and that you are deploying. So do scan those, scan the workloads, making sure that at least from that side you can detect when something might be happening, or at least if new vulnerabilities are being discovered, that they might also be implying you in this case. Do take into considerations identity and access. It is key. It's sometimes tough to manage, but it's really necessary in order to make sure that not everybody will get access. And don't forget that multi-factor authentication, it is as easy as it is today to implement, but sometimes just simply forgotten. And then in terms of application security, obviously, use basically principles to do analysis on the developments that you're doing, and do also follow the route of advice on management capabilities, for instance, patching, and making sure that those patches, of course, are also there in a secured way. In terms of containers, do understand what software you're running in your containers. They might become black boxes. And so you might not see which types of security vulnerabilities you might bring along. And then you're also exposing not only yourself, but sometimes maybe also your partners too. Make sure that you can at least facilitate the way to automatically update them. You still will be able into control, of course, to send out the updates in this case. So do check those. But it will help you in any case in improving on a continuous basis also the assessments of the containers, because of course those will also be impacted by new and upcoming vulnerabilities. So if you have containers which have been sitting there for maybe half a year, and then you try to deploy them, then it might be a bit of an issue when it comes to security. And so do take a look into the upcoming white papers, both from OpenCloudification, from LSEC, and from the CSA. Things like those top cloud attack vectors, or security guidance for critical areas of focus in cloud computing, which is already there in its version 5. And so many of these things will be also reporting again on the OpenCloudification website, and showing you potentially also some additional things towards the future, and a topic specifically on, for instance, key management and how to deal with crypto in the cloud is definitely a next topic that we can start to address. But take into consideration some of the other CSA deployments and white papers, which are definitely of interest to you if you are considering, of course, the use of cloud. So with this, as also Luca mentioned it earlier, you will see this, of course, also afterwards in being published on our website as a webinar, and we will definitely also share the slides. But do reach out to us if you care for more information, or if you would like to see basically some practical implementations and be trained by us and by our partners on the actual implementation also of security tools and security mechanisms. So after just under 2 hours of webinar, I hope in any case that we have brought some additional light in the challenging world of cybersecurity, and definitely also cloud cybersecurity. So we hope at least that you got some interesting insights, and when you are taking the next step into your transformation towards cloud, it is something that we do advise, and that we also say this is indeed the way of the future. But take into consideration that it's also has to be protected, and that even if you rely upon your partners, in this case public cloud service providers or private cloud service providers, that there's still some things for you to do as well and to take into consideration. And if you want to know more about these things, or if you want to know more how to implement it, then please tune in on our hands-on webinars, or do reach out to us so we can find you the right experts to guide you alongside. All right, Luca, anything that we forgot?
I think we said everything.
Okay, at least for today. So our next webinar will be in about a month's time. I think it will be the first week of June, likely. If you register for this one, then you will be automatically invited for the next one. If you haven't, and you're seeing this basically through our website, then just click on the next event on the website, register yourself, and we'll send you the invites for the next and upcoming OpenCloudification webinars and face-to-face sessions. Thank you very much for your interest and attention, and looking forward to seeing you again soon. Ciao.
Bye.